In this session, we're going to try and apply all the new strategies that we've been learning about in this unit in one place. So today's session, we're going to be answering the question of how do I solve problems involving fractions. So we're going to be looking at real life issues where fractions are going to be included. And let's begin by looking back at the previous session and the methods and strategies we used when calculating fractions of amount. Now this was the one where it was a little bit more complicated. So we created a bar to represent the fractions to begin with. So in this case we can see that whatever I'm dealing with, I'm dealing in thirds because that whole bar has been chopped into 3 different parts. And each of those parts has the value of 1/3. We then went and highlighted the fraction that we know. So in this case, I know what 2/3 of the amount is. That's why that's highlighted. And in this case, 2/3 of the amount is 12. So if 2/3 are 12, now I need to work out what the unit fraction is. What is 1/3? So 2/3 are 12. Half of 2/3 is 1/3. So half of 12 must be the value of 1/3. And here we can see that I've calculated the value of a unit fraction, and 1/3 is 6. The other third is 6. 2/3 are 12. Like we began with originally. And then we can start moving on to finding out what the whole bar is worth by using that unit fraction and filling it into every single one. So we know that 1/3 is 6, another third is 6, another third is 6, and so on until we get the whole bar covered up. This allows us to use that idea of the unit fraction of 6 to calculate the value of the whole bar. So in this case, I've got 3 lots of 6 because my bar is split into 3 equal parts or thirds to give my bar a total value of 18. So when we're looking at a problem like this, we know that we've created a bar to represent the fractions. We've highlighted the fractions that we know. So for this instance, we knew that 2/3 was 12. We've used that 2/3 with 12 to find out 1/3, which was 6. And then we've been able to use that 1/3 equals 6 to work out what 3/3 are, which is 6, 6, and 6. 6 times 3 is 18. So keep remembering back to that strategy because I'll be honest, knowing a fraction and an amount is probably the most complicated bit we'll get. That'll be the part that plays around with your mind a little bit more. So do not worry if you're coming back to this section of the video over and over again in this session. Do it because the more confident you get with this, it really shows your full understanding of fractions. And now moving on to today's session, how do I solve problems involving fractions? And we open up our textbooks and we can see that our first problem in the textbook relates to our zookeeper who's busy feeding the penguins while the monkeys are all looking as they stand on the ground and swing through their trees. And question 1a is asking what fraction of the monkeys are in the trees. So when we're thinking about this, first thing is we need to know how many monkeys are there altogether. What can we use that information for? Then we can work out how many monkeys are in the tree and we can record that as a fraction. So for question 1a, think how many monkeys there are altogether. Then think about how many monkeys are in the tree. Then think about answering that question of what fraction of the monkeys are in the tree. Question 1b goes to what we looked at the beginning of the session in our remember section. And this is where the zookeeper has 20 fish. She feeds 2/5 of those fish to the penguins at midday. And she feeds the rest of the fish to the penguins at 6 p.m. So our question here is how many fish do the penguins get at 6 p.m? Think about the way that you can represent that problem. The zookeeper having 20 fish, feeding 2/5 of those 20 at midday, and the rest of them are going to be fed at 6 p.m. So how much was fed at 6 p.m? How much was that rest of them? And really think about the way that you can represent this. I don't want to say the words, but maybe as a bar model would be useful on this. So now I want you to take your time. I want you to think about the strategies, and you're going to pause this video and you can answer question 1a, which is what fraction of the monkeys are in the trees. And then you're going to move on to question 1b, which is the zookeeper has 20 fish. She feeds 2/5 of the fish to the penguins at midday, and she feeds the rest of the fish to the penguins at 6 p.m. How many fish do the penguins get at 6 p.m? So pause the video, give those 2 a go, and then come back when you're ready and we can look at the strategies that have been applied. Let's begin looking at question 1b. We had the question, what fraction of the monkeys are in the tree? And the first thing I've done is I've gone straight to my bar model This bar model now represents every single monkey on that picture. And how many monkeys are there? Well, I can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 monkeys altogether. So all the monkeys are the whole, and there's 12, so that means I've broken that whole group of monkeys into 12 separate parts, as can be seen by the bar model on the screen now. The whole bar, has been broken into 12 individual parts because there's been 12 monkeys. And to make that a little bit more clearly, there's the 12 monkeys in my bar. You can see I don't just need to use counters, I don't just need to use numbers. In this case, I've used my pictorial representation of each individual monkey. So now I can start thinking about that question, what fraction of the monkeys are in the trees? Well, if there's 12 monkeys altogether, I must be working in 12s. So how many of those 12s are in a tree? And we can see now that I've got 5 1/12ths. So how many monkeys in a tree? 5 12ths. Now this is another way of representing exactly the same problem. What fraction of the monkeys are in the trees? And this is using almost like my part-whole model. So in this case, we have my whole, where here we can see I have my 12 monkeys. And then I have my two parts. I've got the monkeys here, 7, and I've got the monkeys here, 5. 5 add 7 to give me 12, and of course this means that I will have 5 of those 12 monkeys in the tree to give me an answer of 5 12ths. And if I was looking at how many monkeys were not in the tree, in this case there's 12 monkeys in total, 7 are not in trees, so it's 7 12ths. For question 1b, we're asking the question, the zookeeper has 20 fish. She feeds 2/5 of the fish to the penguins at midday, and then she feeds the rest of the fish to the penguins at 6 p.m. How many fish do the penguins get at 6 p.m? So now in this case, I've got some information. I'm going to have to work out how many fish are going to be fed at 6 p.m. And we know straight away that the total amount of fish is 20, so my bar represents all 20 fish. Well, then knowing that she feeds 2/5 of the fish to the penguins at midday, so it means I'm going to be working in fifths, so it means I'm going to separate my bar into 5 equal parts, with each of those 5 parts representing 1/5 of the total. And my next stage is going to be to find out the value of each one of those 1/5. So I'm going to use the normal calculation of 20 shared into 5 groups equally, 20 divided by 5, and that's going to give me an answer of 4. And to double check that I'm correct on that, I can do the inverse. So I had 20 divided by 5 equals 4. 4 times 5 equals 20. So now we can see that 1/5 of my 20 fish is going to be 4. Now I can highlight my 2/5, which is 2 lots of 4, which gives me a total of 8. And you can see I've coloured them in orange. And the remaining amount is in blue. So now the question here was, how many fish do the penguins get at 6 p.m? Well, if we knew that 2/5 of the fish are being fed to the penguins at midday, 8 of them, then the rest, 3/5, is going to be fed to the penguins at 6 p.m. And if we know that 1/5 is 4, then we can work out 3/5 using a nice easy strategy. 1/5 multiplied by 3 gives me 3/5. If 1/5 is 4, then 4 multiplied by 3 gives me 12. So 3/5 of the fish are going to be fed to the penguins at 6 p.m. 3/5 of the fish equals 12 fish in total. Now, as the rest of the questions in the textbook and then the independent work in your workbook are going to involve all the different strategies we've been looking at in this unit, all the different ways of working out unit and non-unit fractions. I'm not going to do a recap because I think the recap here would be, should you need some help on this, should you need some extra advice, look back at the previous lessons. That's where we've done these activities already, and that's where you're going to be best to go back over them. So whenever you get stuck on one, for example, it might be finding the unit fraction of an amount, have a look at that lesson. If it's finding a non-unit fraction of an amount, return to that lesson. If it's a case of finding out the total based on a unit or a non-unit fraction, you're looking at the last 3 lessons that we've looked at in this unit. Those are the core strategies you'll be looking at. So finish off the work in the textbook, Make that decision on how confident you are, knowing that you can go back to the previous 3 lessons to go back over the problems should you need them, or then you can move on to your independent work and give them a go. And I look forward to seeing just how well you've done in this topic. Now, if you're still finding this difficult, don't worry in the slightest, because we're going to revisit fractions again. So all these strategies we've been learning over this topic, we're going to review, we're going to consolidate, we're going to get even more confident with them. So good luck, and I look forward to seeing your work.